Okay, Hydrosafe. We've been considering the installation of the membrane, the usage, the planning process, probably a little bit of the installation, the using of the tape, and now we're having the situation that the membrane has already been installed and moisture is occurring at the building site. What's happening then? Because we were talking about that the moisture could leave the construction very easily due to the variable abilities, but could it be a problem during the building time? There could occur very high relative humidity levels during the building time. And this is what I want to describe, and this is what I want to explain with using Hydrosafe technology. So, at first, I want to read the sentence taken from a German standard, the German standard for air tightness. We've got a standard for air tightness that describes everything, the materials, the needs, solutions for air tightness details. And I've taken the sentence from this air tightness standard. It says the air tightness layer needs to be planned. Who's planning the air tightness layer? You should all do, because otherwise it could be possible yet the craftsman enters the building site, 2 tapes and 1 glue and 1 membrane with him. So now, what do I have to do now? Which details do I have to expect? Should I have brought grommets for cables, for tubes? Without planning, he doesn't know what to bring. He doesn't know what to expect. He doesn't know what to charge in advance. So if he sends you an offer for doing the air tightness work, then it would be good for the planner and for the owner of the building to know in advance what the costs will be after the installation. And this can only be calculated by the craftsman if he knows in advance what he has to expect at the building site. Otherwise, it's a kind of present that you get and you have to open it. So this is written in a German standard. Contracted out, of course. You have to describe what work needs to be done. And executed with great care. Interesting. This is written in a standard, in a German standard. Actually, it should be clear that air tightness products need to be used very carefully and installed very carefully, like Roman has shown you during his demonstrations. But it's written in German standard. Obviously, there's information lacking in the heads of the craftsmen in Germany. I guess it's completely different to the UK. Apart from the craftsmen that are here and following the presentations. But actually, there should be more people visiting these kinds of seminars to see how the details could be solved. And this is the best part of the sentence. The work to be carried out must be coordinated among the people involved on the. As a planner, as an architect, you have to organize that the air tightness installer is able to talk to the plumber or to the person who's installing the windows or to the electrician. Because then you can say, okay, how many penetrations of cables do you plan to have through my air tightness layer? Is it necessary that you install your cables between the rafters, or is it necessary, or is it possible to install it in front of the rafters right after my installation of the air tightness layer? Then, if there is a penetration, you could forward grommets in advance, and he could use it, push the cables through it. You don't have to be at the building site as a craftsman. He uses the grommets, and you can tell him, oh, when you are, if you use the grommets, I come later and I seal them to the membrane that I'm planning to install. And it's much easier for me. So this is why the people have to talk to each other. Most of the things, most of the solutions are much better when people have been talking to each other and organizing the things that could happen where the different work meet each other, the different labor meets each other. This is what's meant by this sentence. So if you are the planner or the architect, organize that people meet each other and talk to each other. It's better to invest 1 or 2 hours rather than to avoid problems occurring at the building sites, rather than spending more time in finding solutions for problems that wouldn't have occurred if you've organized a meeting of the different people. Otherwise, you could get into trouble and get these situations. So a tube and some cables are penetrating the air tightness layer in one hole. How this problem on the left side could be solved. Lots of glue. Tape, use a lot of tape, wrap it around, hope it will be airtight. I don't think that there will be a good solution for solving the problem on the left side. Or at the right side. Obviously, the electrician knew a little bit about airtightness. And he said, okay, I just make a little hole into the membrane and then I push the cable through, but he has no tapes, no grommets available to seal it. So, and if the installer of the airtightness layer will never come back, this will stay in this situation. The cable will penetrate the Intello membrane until, for the next decades. But this is not a sufficient solution for achieving airtightness. Or here, in the bathroom. So for the toilet, we can identify 2 penetrations of tubes that were not sealed properly to the OSB board. And in this situation, it could be possible that they will never be sealed, because in the next step, somebody is installing the gypsum board in front of everything. And then after the building is finished and the people are sitting on the loo, they are complaining about cold air affecting their kidneys. This is happening a lot of times, and I guess that you have found it for a lot of times when you're performing the blower door tests. And you know where it comes from. Unsealed pipe penetrations through airtightness layers. So this is why the people have to talk to each other. You know that I already explained to it, there's no second mark to be won at this situation, I'm sorry. 800 grams per square meter. Just remember how big, how much moisture could get through leakages in airtightness membranes. There's another source for moisture, the storage of the material. I already explained it. Remember the roof of next spring hidden under the snow layer? This could be happen to insulation material as well. You are not supposed to use insulation material that was getting wet due to the weather conditions and install it between the rafters, because then you get in trouble. Even if you install a humidity variable vapor check at the inside and have a diffusion open roof underlay at the outside. This needs to be dry before it could be installed. Or this situation, it's the same as in comparison with the timber. Some people think that the PE foil that are using to wrap the wood fiber insulation on pallets is enough weather protection and the material does not have to be covered. But it's wrong. The PE foil used for this application is only to store the different packages on a pallet. It's not supposed to serve as a weather protection layer. So if you want to store insulation material outside, you have to cover it. Otherwise you could get in trouble, because the foil is not UV stabilized and it could get small holes and then the insulation material gets wet. You know them, street laying people, of course they are having a big influence onto the humidity levels on the building site. And in this situation there's another moisture hidden. Probably you know these situations, and you can see the moisture in the wall. You can see that the walls are wet. Here, obviously, for a couple of days, water was standing on the concrete, and the wall, the masonry wall, the brickwork is saturated with water. What are you doing in this situation as the installer of the insulation and the airtightness layer, or as the architect who is guiding the building site?
You ought to be doing nothing.
Nothing, of course. You wait until the plasterer comes and hides the moisture. Of course. In Germany, the Association of the Carpenters published a brochure for carpenters that producing furniture, and in this brochure it is mentioned that furniture that is put into new houses should be between furniture and walls of new houses should be a distance of at least 5 centimeters, because they've experienced the problem that the furniture was growing mold on the backside due to moisture that was into the walls. this kind of moisture. You can hide it with plaster, but it needs to dry out. So in this situation, you have to dry the walls. Probably you have to inform your customer and say, I'm sorry, we have to invest. If we are under pressure, we have to invest into mechanical drying facilities. We need to get rid of this moisture, otherwise we could get in trouble later on. And all this moisture is rising the relative humidity in your houses during the building time. This is the moisture that we have to deal with. This is the moisture that we have to deal with during the construction time. Otherwise we could get in trouble and a problem could cause within our constructions. And this is not a construction that has been not airtight. This is a construction where a lot of moisture was affecting the insulation material during the building time. And this was discovered by chance, not because moisture was running out of the construction. Somebody found it by chance because he wanted to install additional tubes that were forgotten in this building site. About 24% of building damages are caused by moisture. This is an examination that is published in a book, Learning from Building Damages in Timber Frame Constructing. It's a German book. And you can see visual defects, crack formation, joints, deformation, and most of the problems occur due to moisture in timber frame constructions. So that's where we have to spend the biggest effort in to make sure that our constructions are not being affected. So we need dry building sites, we need low relative humidity levels, but the problem is that the timber frame construction of our masonry wall, of our brickwork house, is always the roof. It's always there. So, and in brickwork, in houses made from bricks, you have got always a lot of moisture to be put in due to the screed, due to plastering. The material itself contains a lot of moisture. So if you install a humidity variable vapor check at the inside of your roof, then this vapor check has to resist the high moisture levels caused by building materials, the work that is undertaken at the building site, laying screed and so on. It has to offer a high diffusion resistance even if the relative humidity levels are rather high during the building time. Because otherwise the material would let a lot of moisture into the construction and could cause their problems with growing mold, for instance. And this is where we have to take the Hydrosafe value into account, because we have got another German standard for wood preservation in Germany. And it says that a humidity variable vapor check needs to have an SD value of at least 1.5 meters at a relative humidity level of 70%. At least 1.5 meters, because if you've got a lower SD value, then the moisture that's occurring during the building time could get into the constructions very easily. And there are humidity variable vapor checks around, mostly made from PA, polyamide, that have got a very low diffusion resistance at 70%, less than 1 meter, less than half a meter. And they allow to pass a lot of moisture during the building time and to wetten the insulation material as well as the construction. And this is a problem. So you have to be careful and you have to check if a humidity variable vapor checks fulfill the requirements of the Hydrosafe value. On the other hand, it shouldn't be higher than 2.5 meters. So it should be between 1.5 and 2.5 meters. Because if it's higher, you are getting less dry out capacity. Let's say at 70%, 100 meter SD value. What SD values do you have to expect at 90% relative humidity? They wouldn't be low enough, because the lower the diffusion resistance is at very high relative humidity levels, the more moisture could dry out. That's why they limited the maximum SD value to 2.5 meter. So Hydrosafe means SD value of the humidity variable vapor check between 1.5 and 2.5 meters at 70% relative humidity, and all the humidity variable vapor checks from Procliva fulfill these requirements. the DB Plus and the Intello Plus have got a fitting Hydrosafe value that secures that even during the building time when the relative humidity levels are rather high, the constructions are safe. Of course, we have calculated this to show you an example, to show that the construction is very safe even if you've got a couple of weeks with high relative humidity levels. And we have taken a flat roof construction, flat roof membrane on top, timber decking below, insulation material fibers 240 millimeters, and various vapor checks at the inside. And he is causing the biggest problem because he brings thousands of liters within 2 days into our buildings. And this moisture needs to dry out, but the Screed layer says, please keep the windows shut for at least 5 days. Otherwise we could get into trouble. If my Screed dries too quickly, then it gets cracks, it bends upwards next to the walls. So please keep the windows and the doors shut. So then we have got a relative humidity of 90%, could be possible. A rather high temperature due to the chemical process that is happening within the Screed. And then we have to take into account the customer that says, let's install the Screed right in front of Christmas, right before Christmas, because then we've got 2 weeks off, nobody is working on the building site, and we can use these 2 weeks to fulfill the requirements of the Screed laying people. Yeah, okay, so we have been installing Screed at the 20th of December, and then they closed the building site. Windows shut, nobody was entering the building site anymore. And actually it was planned to start working at the building site again at the 1st of January the following year. What happened? Nothing. The person who was planned to install the gypsum board, the people, they were ill for 2 more weeks. So they kept the doors and the windows closed. And now we've had 4 weeks of 90% and temperature of 20 degrees. What's happening in our timber decking? Because this is the most affected layer when considering moisture contents of constructions. We have performed a woofy calculation for that, and we performed the calculations for an Intello membrane, for a vapor check with 2 meters, 5 meters and 10 meters SD value. And you can see during the 4 weeks, all different vapor checks lead to a rising moisture content of the timber decking. It doesn't matter if you use a constant vapor check or a humidity variable vapor check. But you can also see that the more diffusion tight the vapor check, the less moisture is getting into the timber decking. So after 4 weeks we've got about 18% with SD value 5 and 10 meters, 20% with 2 meters SD value at the inside, and 21% with the Intello membrane. What do you think is the maximum moisture that timber should face, the maximum moisture content that should be in the timber?
18 to 20.
20%, yes. And why 20%?
Because it increases its risk of wood rot and insects.
And when does the rotting process start? At 20% or higher? They've chosen the 20% because they were checking the moisture content of the timber with a hygrometer, yes. They didn't know if they find the wettest spot. So they decided to put a very large security to say if it's below 20%, there could be spots with 22, 24, 25, whatever, but then we are on the safe side. And actually, it is okay to have 24 or 25% for a very limited period of time. So the rotting process is not starting then. But this is only possible if you perform a hygrothermal analysis. It's not a problem if we exceed the 20% for a couple of days here, because this is only 4 weeks. And now I've extended it to a couple of years. And the 4 weeks is the thin red line at the beginning. So you can see that with the Intello membrane it decreases to 22%. Then after a couple of months it dries out and gets balanced of about 15% humidity content in the timber decking. while the other membranes are still gathering moisture and they are not able to dry out this moisture content. They are gathering moisture for the construction, and this is the situation where the timber decking would start to rot. A very clever guy from Finland called Viitanen, he developed a method to find out if, even if we are having 20% or more, if the timber is safe or not. And he invented a wood degradation model that is dependent of the water content of the pores within the timber in dependence of the temperature. So if you've got rather low temperatures like 0 degrees, the water content of the pores within the timber should be below 95%, and if it's rather warm, it should be below 85–87%, because everybody knows when it's freezing, mold is not starting to grow. But if we've got 0 degrees or 10 degrees, there could mold growth occur, and in dependence on the moisture content of the material. And this is included into the hydrothermal analysis tool from the Fraunhofer Institute as well. And when we apply the results of our calculation to this method, then you can see if we stay below the red line, then the construction is safe, even though we have got higher moisture contents in the timber layer, more than of 20%. So this construction is safe because none of the calculated moisture contents of the timber decking has got more moisture content than described with the red line. We are always staying below. So the construction is safe, even if we've got a couple of months with 20% water content in the timber and more. That's why it's very important to have a membrane suited with a Hydrosafe value. Of course, you're not supposed to store timber frame constructions under humid conditions for years or months. You have to make sure that the relative humidity levels should not exceed 60%, 65% for a long period of time. But if you've got rather small time periods with high relative humidity levels, it's not a problem for the construction if you've got a membrane with the right Hydrosafe value between 1.5 and 2.5 meters at a relative humidity of 70%.